Hey everyone, I'm Chris, and this video is going to be a deep dive into a core feature of NeoFPS, MotionGraphs and the MotionGraph editor. So, what is it? Well, a motion graph is a state machine similar to Unity's animator state machines, and it's used to enable developers to design and iterate complex movement mechanics through an easy-to-use visual interface. Now what that means is that you have a graph editor that lets you connect movement states together and then control when and how a character transitions between them as they move through a scene. So first up, how to access the MotionGraph editor. The first way is through the toolbar by going to Tools, NeoFPS, MotionGraph Editor. You can then select a motion graph to edit using the field at the top left. You can also create a new graph from within the editor by right-clicking in the project view and selecting Create, NeoFPS, Motion Graph. With a motion graph asset selected, you'll notice that the inspector view for the asset is just a Show Motion Graph Editor button, so you can also open the editor that way. Selecting a motion graph asset in the project, or selecting a game object with a motion controller component that references a motion graph, such as the demo solar character prefab, will switch the graph that is currently being edited. You can also select character in play mode to see the graph updating as the character moves around and switches states. Right, so let's run through the editor and how to use it. On the right here is the viewport, which you use to build the graph, and on the left is the motion graph inspector used to edit the graph elements and the custom properties. I'll come back to these later, but for now let's concentrate on the viewport. So the viewport can be moved around by holding the middle mouse button and dragging, or if you're using a trackpad or similar, you can move around by holding the left Alt key and left click dragging. Left clicking on a graph node will select it, making it visible in the inspector. You can also select multiple items using the left control key or by left click dragging starting on an empty area of the viewport. Left click dragging on a node will move that node or multiple if the node you started dragging on is part of a group selection. You can also left click the arrows on connections between nodes to inspect that connection, though these cannot be group selected or moved. Right clicking in the viewport shows a context menu depending on what was under the cursor when you clicked and what you have currently selected. Looking at the contents of the graph, the rectangular nodes are motion states. A state controls the actual movement of the character, such as a falling state or a jump state. You can create a new state by right-clicking on an empty area of the viewport and selecting Add State, and then the specific state that you want. More states will be coming in future updates, along with all kinds of other goodies to expand the motion graph. The nodes with bevel corners are subgraphs. Subgraphs are a means of grouping and organizing states. You can enter a subgraph by double-clicking on it, or by right-clicking and selecting Show Subgraph. At the top of the viewport, you can see a breadcrumb trail that shows where you currently are. The green subgraph in the viewport is the subgraph that you're currently viewing. Double-clicking this will take you back up to the parent subgraph. You can also right-click on it, or on an empty area of the viewport, and select Show Parent Graph. You can add a new subgraph by right-clicking in an empty area of the viewport and selecting Add Subgraph. The lines that you see between nodes are graph connections. You can connect two nodes by right-clicking on the start node and selecting Make Transition, and then left-clicking on the end node. These connections have a number of conditions, which, if met, will cause the graph to transition from the start node to the end node. However, it isn't just the current state's connections that are evaluated. Each of the parent subgraph's outward connections are checked first, starting from the root of the graph. For example, let's say we're currently in the crouch state, and we want to check for transition before moving. Crouch is in the controlled subgraph, which in turn is in grounded, which is in movement. So first of all, the connections out of the movement subgraph are checked. Have we contacted one of the ladder types? No. So we move on. We don't check the connections from the movement subgraph to its children, as the point here is that we're checking if we should exit the current subgraph. So we know movement is fine. We now check each of the connections out of the grounded subgraph. Have we jumped, dodged, or lost contact with the ground? Let's say no, so we move on. Is the ground surface above the slope angle that means we start sliding? Again, let's say no, so now we're back to the current state. So we check the outward connection from this. Is the crouch input switch false? And do we have the headroom to stand up? If not, then we stay in the crouch state. If so, then we transition to null, and the connections out of that state are evaluated until we find the state that we should now be in. So the connections are evaluated in this kind of root to current node order to allow certain conditions and movements to take precedence over each other. The ladders are a really good example of this, as it really doesn't matter if a character is running, walking, or falling. If they attach to a ladder, then they should switch to the relevant ladder state regardless. Now, another thing you might have noticed is the orange nodes. This is the default node. When entering a subgraph, the connections from the subgraph to its children are evaluated in order. If none of their conditions are met, then control is passed to the default node. The first node you place inside a subgraph will automatically be set to the default. However, you can also right-click on any other node and select Set Default if you want to change it. So that's everything in the viewport and an overview of how graphs function at a high level. It can be a little bit tricky to get your head around at first, but it's super powerful once you do. Okay, now let's look at the Motion Graph Inspector on the left here. Selecting a graph node in the viewport will show it in the inspector here and allow you to modify its properties. States and subgraphs both have a number of properties in common. You can change their name here, and you can change the order that their connections are evaluated by dragging the connections up and down in the Out Transitions list here. If you select a connection, then you could see its conditions here. You can add a new one by clicking the plus button at the bottom of the list and selecting the relevant one. Character conditions are based on the character controller or other components in the character hierarchy. Debug is a simple condition that can be used to evaluate and debug the flow of your graph. Graph conditions are dependent on the graph itself, such as the amount of time that you've spent in the current state. Physics conditions involve things like raycasting from the character's location. And lastly, property conditions are based on the custom properties applied to the graph. You can change the order the conditions are evaluated in by dragging the handles on the left around, and remove them by selecting and then hitting the minus button here. Lastly, you can change whether the connection should only transition if all the conditions are met, or if any one of the conditions is met. We'll take a look at inspecting states now, but there's two things to cover that are relevant to that. If I select the jump state here, and we look in the inspector, one of the properties is a drop-down called charge property. This references one of the custom properties on the graph, and if we click the custom properties tab at the top here, we can mess around with those. So the custom properties are just like the ones that you would see in the animator parameters list, with a couple of additions. A switch property, which is essentially a boolean, and a transform property. One other major difference to the animator parameters is that you can also store a reference to a property for quick access instead of having to access it by name or hash each time you want to use it in your scripts. Each property allows you to specify a name and a starting or default value. You can add new ones using the plus button at the bottom of the list and then selecting the property you want. I'm going to add a new property called newJump with a default value of 0.5. And now if I go back to the inspector and the state that we were just looking at, then I can select the property from the drop down here. All of the custom properties can be accessed this way from within the graph states, conditions and the like. The other thing to mention is the jump data key here. Alongside the motion graph, a character motion controller also references a motion data asset. This provides a way of separating the movement logic in the form of the motion graph from the data so that they can be interchangeable. You might want to use the same graph with a variety of different characters with different body types and therefore different stats like speed and jump height. You can find an example alongside the graph that we've been editing here, or you can create your own in the project view by right-clicking and selecting Create NeoFPS Motion Data. Looking at the example included with NeoFPS, you will see a number of sections for different data entries. The key property of each one corresponds to the key property on that state in the motion graph editor. You can add new data entries at the bottom here by clicking on the Add Data dropdown and selecting the relevant data type from the list. I'll be looking at ways to improve this workflow and make it a bit more reliable, but for the moment, if the keys in your graph and your data don't match properly, then the graph will just use default values and nothing will go crazy, but it's something to be aware of just in case things aren't behaving exactly how you're expecting. Back to the motion graph editor, and the rest of the properties on a state will be unique to that state type. You can always access the documentation for each graph element by clicking the icon next to it here. And the last thing to look at is motion graph behaviors. These are attached to states or subgraphs and are updated each fixed function movement frame. For example, the crouch state here has a number of behaviors attached to it. This one sets the height of the character on entering and exiting the state. These ones block or modify a number of custom properties on the graph to control the flow. This one handles footstep audio, specifying a step interval, a footstep library, and even casting down to check the surface type for each step. This last one lowers the ground friction on slopes if no input is detected, and then raises it back up again when the character starts moving. You can add a new behavior by clicking the Add Behavior dropdown and selecting the desired behavior from the list. So, that should have been a pretty thorough guide to working with motion graphs and give you some idea of how powerful they can be. Remember that at any point you can click on the help icons to be taken to the relevant page in the NeoFPS documentation. Thanks for watching. If you have any questions, then please get in touch via Twitter using @yondernauts. You can also visit the website at neofps.com for more information. All the links are in the description below. Have fun and let me know how it goes.